thank you everybody for having me over here today. My name is Vadim, and I'm a co-founder at Imply, which is a company that's about Druid. It's actually the company that we, the founders of Druid, we kind of started it. Druid started up as in a company called MetaMarkets, and then we left and we started our own company called Imply. And I was actually the first Druid user in the universe. So later, after this presentation, you can come up to me and you can maybe touch my hand and you can be like, oh my God, I touched the first Druid user in the universe. I'm also a Druid committer, and I'm passionate about user experience. In fact, I'm not actually a database person. I'm more of a user experience and how do people like work with things person, more of front-end development. And I'm recently been on this quest to rethink Druid's user experience. Well, why did I set up on this quest? Well, what is Druid? It's known for kind of three things. It's fast, so you have sub-second interactive queries, which is really cool. You issue a query, it comes back straight away, really nice. It has real-time ingestion, so you have instant data visibility. If you're connecting to a system like Kafka, you can be ingesting data, and you can query on data from like 5 years ago to like right now, and immediately see the whole thing aggregated. And also, it's scalable, so Druid scales really well. You can have thousands of machines. Like the biggest cluster I know of, I think, is 40,000 machines, and 4,000 machines. And it has petabytes of data that it can scale to, so it has really nice scaling properties. But Druid is also known for being hard to set up, not very user-friendly, and a little complicated. And this is kind of this is a sad one. The fourth one is cool. So I want to change that, and I really am on a quest to change it so that people will actually tell, like when my goal is that people like talk about Druid, they say, Druid is like the most user-friendly database in the world. It's so cuddly. It's my best friend. I tell it all my problems, and you'll see when I talk about that in a second, what that means. But yeah, I want people to actually recommend Druid to people, not just because it's fast and it's the only database that can scale to your needs, but also because it's the nicest database to use. And I want to talk about what we're doing right now and what kind of what has been the evolution and where this is going. And I think part of this talk will be, I'll talk about some stuff that if you are trying Druid out for the first time today, like other than this talk, you won't ever see this. It's like historical things at this point. Some things you will see remnants of, but they'll soon disappear. And also some things that are yet to come. So if you're using Druid, you should get excited about this. And the majority of my talk will culminate around this, which is a web console that we've been building and designing and contributing to open source Druid. So I just want to be clear, at Imply, we do a lot of tooling around Druid, like that's the whole company. But everything I'm talking about in this talk, 100%, is going to be stuff that's part of the open source Druid distribution and what you get when you download open source Tarball. And this is also how I became a contributor to a Java project without ever writing a line of Java, because Java sucks. So I want to talk about this in the context of these three things that I think make up any data system. Not just a database, just anything that actually stores data is made up out of ingestion. You have to get your data into it somehow. Querying, you have to somehow get the data out. And management, well, you have to manage it and you have to manage the data inside of the system. And these are the three things on which we kind of, these are kind of the three use cases for what you would do with any database and how we break the system down. So I'm going to talk about all the improvements that we've been making on these three axes. Let's start with querying. So when Druid came out, one of the things that you kind of either loved or hated about it is that Druid queries were very low level. Druid had many query engines. You could choose between the one you like. So this is a top-end query. You could extend Druid with your own query engine. So it's a very extensible system because it uses Guava under the hood. And you had to write this like JSON blob to query Druid, which is actually okay if you're writing it from a from some sort of an application, because like you have like probably some JavaScript or something that's generating these JSON blobs. But it's actually really hard to get started with because nothing about this is obvious. You have to read documentation to understand any of these fields, and it's really a pain in the ass to like even start writing the very simplest query. Semantically, though, this is very similar to what you would do in SQL. This is just like a group by on comment and sort on count, which is an aggregate by count, and take the top by of 50. So this is like what top 50 comments I have by count. And what's nicer than having to write nasty JSON like this? Well, it's SQL. That's pretty much a no-brainer, but this was really the first thing we did in Druid to start actually improving the kind of user experience here. So Druid integrated Apache Calcite, which is an open source query planner, and you can now issue SQL queries to Druid. So this is the same query that I had on the previous slide, but expressed as SQL. And the advantage of SQL is that it's just something you probably already know if you are in the data world. And you don't have to really learn how to write SQL. You might need to learn which specific functions Druid supports and maybe certain peculiarities about this flavor of SQL, but in general, it's ready to be used. And this is now production ready. So Druid right now is in version 0.16. In 0.15, we've been experimenting for this for a while. This has been in an experimental state, meaning that you can use it, but we're still not like putting 100% of our weight behind it. Since the previous release, we've now declared this to be completely stable. We have people running this in production. A lot of people running, I mean, most new people are actually running this in production. This also allows people to connect other UI tools to Druid. So at Imply, we have a UI tool that we built called Pivot, but there's plenty of tools that work with Druid, actually thanks to the SQL compatibility. So if you want to integrate with Looker, if you want to integrate with Tableau, it's done through the SQL layer. And actually, we partnered with Looker, and they helped us. Kind of, they were like one of the first initial people that gave us feedback on how to do this. Next is we actually built a nice query interface inside of the console. So this is a console. It's built into Druid. So if you spin up Druid, you can go to a certain port, and maybe I'll have time to show off a little demo later. And then you actually get this console, and you can like play around with it. And one of the cool things here is you basically have autocomplete here, which is really nice. It actually compiles the Druid documentation into the console itself. So whatever is here is byte for byte whatever is written on the documentation side. So you can actually, if you think, oh, like does Druid support that function, just start typing it, and you'll discover that. It's also really nice to actually just run queries on. When you're setting up a server, you probably, before you put your application on it and your whole BI team is using it, you might want to try to run a few queries yourself. One of the things we actually did is because this console understands the Druid SQL language at such a deep level, so it can offer all these autocompletes, we actually decided to go a little bit like one step beyond. And what this slide is about is the fact that you can take any of these SQL queries, and you can actually click on a button called Explain and get a nice plan of how this actual query will plan into the native Druid query. So here's that top-end query, which is actually really cool, because if you want to learn how to use the native queries because you want to use them for something, there's a lot of things you might want to use them, especially if you're like developing your own query engine extensions. You might want to query them directly, or if you're just like a badass and you write assembly code and you don't trust compilers, or maybe you're like worried about the 1 millisecond delay that the SQL planning introduces, then you know, if basically I want to say if you're doing math, then you want to have check this out, and this is a great way to learn. You just type in your favorite SQL, click on a button, and you got it. So we went a step beyond because we have so much query intelligence in this console now that we actually decided how to do, like the problem with SQL is that A, people sometimes don't know how to write it, what is the actual function that you have to write. B, some people write SQL in lowercase. Like, what's up with that? I know SQL doesn't care about case, but like, come on. The whole point of SQL is that you're shouting at a database. I feel like anybody who writes SQL in a lowercase has missed some very important class on SQL. So this UI right here will actually let you write your queries. So as you can see, as I'm clicking around, well, as in the GIF, as it's clicking around, it's actually changing the query here and adding filters and rewriting the query. So it understands what the query is, and it can logically transform it as you play around with it.
So this kind of replaces pivot. It can.
This is answering the question of what would happen if pivot and SQL had a baby. An alternative way to think about this is if you are like the person that's setting up Druid, if you're the person that's setting up this console, this is my love letter to you. I think you're a valued person, you deserve to be happy in your life, and you should have a tool that respects you. I think a lot of databases have like tools that the built-in consoles are sometimes like not thought through very far. And I thought, man, the people who are setting up Druid, they're going to be like our champion. You know, thinking about this with my business hat on, they're going to be like our champions for Imply. They're going to be the ones that are like getting us through procurement. So we better make them love us because they're awesome. All right, so that's querying. Querying is really fun. And I can talk a lot about querying, so I'm like my whole life has been around querying Druid for like, since like probably I think 7 years ago to 1 year ago, I've only been querying Druid. And then I decided to get into other things as well. So management. Some people would approach Druid and say, man, Druid has so many processes. What is going on here? Druid has a lot of processes. Look at all these circles. I actually forgot some of the, I had made the slide and I forgot what the processes were because there are so many. Now, this is like a great thing if you are running a cluster at like 1,000 node scale because you will want to tweak the JVM configurations of every single one of these and super optimize your hardware. Remember, Druid was built by a cash-strapped startup, so it's trying to make it so that you can run it as efficiently as possible, and by efficiently I mean cheaply. But this is way too much, and it's not clear what all of these things do. So one of the things we did was we really took a look at this and said, okay, how can we make this simple? We had two processes that were around, like making sure the cluster is doing what it should be doing. They should just merge into one. This whole middle manager peon thing, I'm not even going to go into that, but just needs to be simplified. And there was an Apache Hadoop dependency that if you really needed to load batch data at production scale, you actually needed to set up a Hadoop cluster. And I'm so happy to say that this is going away. It is almost gone away in 0.16, which is the current version, and it will be completely removed in 0.17, which is the one that's going to come out.
What's the alternative? Because we use it.
Druid will do it for you.
Oh, you mean the streaming?
The native Druid ingestion will be able to do everything that Hadoop can do. In version 0.17, it can do almost all the stuff it can do in 0.16, but 0.17 is when it will complete. And I have like a cool timeline of it at the end of this presentation.
Do you implement the storage there?
No, so when I say we remove Hadoop, I mean we remove MapReduce Hadoop. HDFS is cool. If you're using HDFS for stuff, we will read from. We'll like still work with HDFS. Just as aside from this meetup, just putting on my Silicon Valley hat. Hadoop is dead. All right. Like it's a dying technology. It's dead. I mean, maybe it's dying. In Silicon Valley, it's dead. Like nobody's using it. HDFS is cool though. It's still cool. So if you want to be cool, HDFS is still in. Okay, so this is what it looks like now. we've actually have a concept of just a master server, a data server, and a query server. And inside of them, they run these services. So there's only a coordinator service. The master also runs Zookeeper. There's a data service that is like doing everything to do with data, which is serving historical data and indexing new data. Asterisk, because the indexer is currently experimental, but it will be not experimental very soon. And query, which is just everything you need to query, including the router, which is a really cool node that can actually give you access to every other node in the cluster. And it's the thing that serves that console, which is why the console can talk to everything. And what does that actually mean when it comes down to like the actual executables? Well, if you download Druid and you look at the bin and just look at everything that starts with start, then you'll see all of these cool things. And first of all, there's actually a number of quick start configurations that are tuned to really small machines. So nano quick start is if you have like a cool MacBook Pro. Micro quick start is if you have like a less cool computer, like a Raspberry Pi. Single server is if you're like, it's a real like instance, I don't know, like some Amazon instance, and there's like a table in the docs about like which one corresponds to what. And then there's this cluster data server, cluster master, and cluster query. So you just start the query, the data, and one of these, depending on whether you have a Zookeeper already running or not, lots of people do. And it will start all the processes. It's actually a really nice script under the hood if anybody likes to see a cool script written in Perl, I think. Check it out. The script is cool. The Perl isn't cool. And then when you start it, so here I'm starting the micro quick start. It actually starts all the commands for you, and it will keep monitoring them. It will like set up all the logging for you. Initially, like back in the day, and when I say back in the day, I mean like 2 quarters ago, you had to run like 6 commands to start Druid. Now it's like nice and easy. You just run one command, it just starts up. It's actually ridiculously easy right now. So I'll show this off later. Then there was management. So how do you manage the actual data once you get Druid started? Well, you had these 2 consoles that were frankly written by people who are back-end people. And I'm not going to say anything more about that, but that should really explain what I'm talking about here. You also had 100, like more than, I think 127 API endpoints. So basically, if you needed to do something in Druid, you needed to choose one of these consoles. One of them did one thing, one of them did the other. Which one, I don't even know, I can't tell you. I can tell you, of course, but I'm not going to. And choose one of these APIs. It's kind of like that scene in Indiana Jones where you have to choose the right like chalice, and you better not choose the wrong one, or else you melt. That was the Druid experience. So that actually all got replaced. The 2 consoles have gotten replaced, and now everything that they did and more is served by the one console that is styled by a person that has eyes. Also, the APIs have actually been replaced by system tables. So one of the cool things about SQL is that you can use SQL to also get metadata about the status of Druid. So you can see, okay, like there's these tables called the system tables, and they're virtual tables that you can query with SQL, but they correspond to resources that are actually running inside of Druid. And this entire console is powered by system tables wherever it can, and then whatever API, whatever actions it can't do with tables, it does via APIs. And the goal of the console, that's kind of like basically stated, is that no API you would actually want to use, you would need to use curl for. So I think that having to write a curl to manipulate the database is inhumane. And I believe that you should be clicking buttons instead. And you can also always, like this console runs directly on Druid, so it's using these APIs. So if you look at the network tab of what this is doing, you will see like a perfect example of how to use that API. And lastly, every single view in the console that's powered by a system table you can actually open it and see it as a system table. I've actually heard some people refer to this as their favorite feature of the console, because if you think about the use case, whatever view you have here, and you can get like pretty interesting and filtered in, you can actually take this data here, and you can basically, oh, like I want to see if like this condition is met. Open the SQL, look at what the SQL does, and then if you want to do some alerting on it, just like have like something that runs this query against Druid on every period of time and alerts you, or like alerts your pager duty. It's so simple. So this is what it looks like to use this. It's just as you'd expect. You kind of just like click around. You can like here kill a task, and the task will die. And then you go to like the segments, and then you might drop a table, because you know when you're like loading data, you're playing around with Druid. You can like you can see, oh, like this is my distribution of segments. Oh, like there's that data source I loaded for a demo. Why do I still have that? All right, like open it, and then like drop it, and then drop that data, and drop it like it's hot, and then just refresh a couple of times. It's a distributed system, so nothing happens immediately, but everything happens pretty soon. And you see it says like there's 2,831 segments pending drop, and now you refresh again, and it's dropped, and it doesn't show up in the segment timeline, and your cluster is more free. And that's what management is all about. I think with the system tables and wrapping around all of the APIs, the management of Druid has gotten dramatically simpler. Again, if you're like inspired by this now, and you go and install Druid and you start using all of this, then like you can treat this presentation as like the old man being like, in my day, we had to walk uphill both ways to school. Okay, so let's talk about ingestion, because ingestion was really probably the biggest pain in Druid. Ingestion in Druid looked like this, and you can't even see it, but the projector does justice to how easy it was to ingest stuff in Druid. Maybe just squint your eyes and look at the shape of it. It looks like some sort of a JSON. It is some sort of a JSON. And it's something that you had to write. It's a JSON spec that describes how you want to ingest your data, because Druid has it has a concept of a schema that at least is applied transiently from segment to segment. And it was kind of annoying to write. This has been replaced by the console that has a pretty cool thing called the data loader, which I haven't really seen built into databases like as standard, but I think it's really neat. So this was the old cycle of how, like this is what your like work cycle, this is you. If you were to ingest data into Druid, like with the specs. So first of all, you'd start with the documentation, you copy paste some spec that looks like about right. Maybe it's from a blog post that talks about ingesting data that's kind of like yours. Then you'd edit it a little bit, submit it to Druid, check if it works. If yes, you're good, but if no, you probably have to go read the docs and edit the JSON again. And this cycle would take 30 minutes. I mean, the submit to Druid step would take like 5 before you understand if it works. You might have to read the logs to understand if it actually did what you wanted. Then you have to query it somehow. The docs, you have to read them. You probably get distracted by Twitter. Then you go on Reddit. Then you're like, wait, what was I doing again? Then you forget, go to lunch, come back, and the cycle continues. So 30 minutes is optimistic. I mean, it's very easy to get sidetracked in today's world. In the console, it's a lot simpler, and it's actually a lot more pleasant, because this whole cycle is like almost, it's basically interactive. It is interactive. You select the data location, you play with the UI until it does what you want. You have a live preview that sends your pending spec to Druid and gets a very quick response from Druid evaluating how your data will look like if you were to ingest it like that. If that spec, the live preview looks correct, you're basically done. You have to submit, but that's just a formality. It's definitely going to work. If it doesn't look right, then you keep playing with the UI until it does. And this cycle is very easy to complete without getting distracted and without losing the will to live. And this is how the first step looks. This is the selecting the source of data. So you have all the sources that you might want to connect to here that are supported with the extensions that you loaded. Some are grayed out. If you click on them, it tells you, oh, you're missing such and such extension. And you have like really cool stuff here. For example, you have reindex from Druid, which is a way to read Druid data from itself into itself. It's very useful if you want to drop a column or delete some rows, maybe for like GDPR stuff or to increase performance. And most importantly, paste data. Paste data, you can actually paste data from your clipboard into Druid and ingest that. Some might say, oh, this is pretty useful for people that, you know, just like slack you a couple of rows of data and you're like, hey, like, how would I ingest this? But I'm gonna just stand here and make a bold prediction that like right now we're seeing the world move from batch data into streaming data. I think the next iteration of that is you're gonna just type data from your head. We're not gonna collect data into Kafka. You're just gonna have users be nice and type data directly into the database's web console. This is the future of data right here. You heard it here first. When in 30 years everybody's ditching their Kafka for the direct data entry keyboard, you'll be like, man, that guy was really ahead of his time. And this is how ingestion looks. I guess so. I guess GIFs start in the middle inside of a presentation, or maybe it only happens if you fast forward quickly through it. So let's wait for it to loop. It has a time when you need to actually wait for it to start running. Okay, so I think this is gonna, oh my God, it's gonna query the data. All right, there's the loop. So, okay, start, click on Apache Kafka, connect, enter some Bootstrap servers, enter your topic, and you get a live preview of the raw data in the topic, which is really nice to make sure you're connected to the right topic. It will guess the format of the data based on the live preview. It will guess the time column which you need. You can apply row-by-row transformations. You can apply row-by-row filters. You can configure the schema, which this is the important step, where you can like mess with the roll-up. And this is the step where your cluster can either be really expensive or really cheap, depending on what you do. And then go through all the things with inline help for every single field. Again, compiled directly from the documentation. So you don't actually need to open the documentation if you're using this, because every single field you might want to tweak is just like a little helper thingy inside of this console. So let's look at this timeline. This is the slide that's really meant to be, this slide is here if you're using an older version of Druid, older than 0.16. It's meant to give you a feeling of FOMO, fear of missing out, and cause you to upgrade. So if you're like some people, and those people are people who have Druid deployed for them by Hortonworks, are on version 0.12, which is like, man, I feel sorry for you. Because in 0.13, Druid SQL was introduced. And then came the system tables. In 0.13 came the system tables, which really are a game changer for operational stuff. There's also auto-compaction, which is a killer feature because you know, if you have lots of segments happening, you might want to make sure they're optimal in size, and it would be cool if Druid just did it for you. The new console was introduced in 0.14, so if you're before 0.14, you're in the land of like having those two consoles that were designed by backend people. 0.15 is when you can actually drop and reload data from the UI, and you can autocomplete in the SQL view, and you can configure lookups and like query time lookups and stuff. And then the interactive SQL view, where you can actually like write your query for you, that came in 0.16. That's the last release. Also paste data, most important feature. And then 0.17, which we're actually just about to code freeze probably next week, is a lot of really cool stuff actually around binary files, HDFS stuff, and this is really the point is to kill Hadoop. So if you're using, like right now, if you have your file stored in HDFS, unfortunately, you still have to set up Hadoop. 017, bye-bye Hadoop. We're going to remove so many dependencies. It's going to be great. All console views in 017 will be able to be powered by SQL systems tables. And there's even a cool feature. This is kind of jumping the shark a little bit. But there's a whole Druid doctor, which is like a thing that will scan your cluster for you and tell you if you need to optimize it. It's pretty advanced. Anyhow, I'm really looking forward to this release, but 016 is already definitely good enough to start playing with. So I talked about these three things as the pillars of a data system, and I actually lied. I thought a triangle would be really cool, so I fit my talk into three things, because there's a fourth thing that's just as important, which is, oh my God, community. You know, a real-time project, you want to have an awesome community, and we have a really cool community in Druid that you can, like, if you are setting it up and if you're going through the journey, you can find all the links to this in Druid, the apache.org/community, and especially advocate you join the Slack channel, because if you know it's real time and it's a real time database, real time ingestion, come on, it just fits. Yeah, like all of the Druid committers hang out there, and it's a pretty cool place. And we're growing like really a lot. Like we're the second biggest channel right now in the Apache Slack space after Apache Beam. So if you all join, we can become the biggest one, and it'll be really cool. Also, star us on GitHub, because we love stars. And you're thinking, wait a second, this whole community thing hasn't brought up the web console once. Well, surprise! You can access all the community stuff from the web console. Under the question mark, you have about, docs, user groups, ASF Slack channel, and a link to the GitHub. So that is what is happening right now for Druid. So for the demo, I just wanted to go through the Druid quick start right here, with one hand, because I'm holding the microphone with the other hand. So I have a terminal right here, and I'm just going to start the quick start by running this one command. So I've already downloaded and extracted the tarball because, well, I didn't want to download like a 270 megabyte tarball on whatever Wi-Fi I'm on. But here it is, it's running, and as you can see, it started up all the services for me, so I just had to do one command. And I use the micro quick start because that really fits my laptop well. And because I have other stuff running as well. This is not my only program, guys. This is multitasking. And now I can just open a new tab and go to localhost 8888, which is the port of the router. And I'll get the Druid console that is reporting handily that I have 0 data sources, 0 segments, no supervisors, and pretty much nothing. So this is a blank Druid cluster. It's a fresh cherub. It's an empty state. And I can start by loading some data. And let's see if, OK, so actually I'm just going to go with the example data set that there's just some a JSON GZ file uploaded right here. But the only thing that this example set up is just, it saved me from having to type that in, because it would be annoying to type that in. But as you can see, it's giving me a preview of the data there. You can actually enter any HTTP URL, give you a preview of it. You can ingest an HTML page. Good luck with that. And then you parse it into columns with JSON, I guess. You could select a different parser here if you just want to like break it a little bit to see what will happen. So try it as a CSV, and this doesn't work as a CSV. Well, tell it, well, maybe it has a header row, and it looks like nonsense, which is exactly what it should look like, because it's not a CSV, it's JSON data. So this is the live preview I was talking about. I'm going to switch to my dominant hand for the actual computer manipulation. And then the next step is, very importantly in Druid, is to make sure you get your time column correct. Because Druid partitions primarily on time, And if you don't have the time column set correctly, you're going to have a sad time. But again, it auto-detects the time column for me. So it actually scans through all the columns and sees which one is likely time. And please try it with your own data in your own file. But in this case, it detected it. Next, it allows me to do a transformation. I could actually, for example, go in. Maybe I have added, and I have added plus 5. And I'll just add an expression of added plus 5. And add that. And there I can see the preview of that column. I could obviously get a lot more fancy than that. And I can click next. I could filter some data out. So for example, I could filter only data that's like of a certain page. And then I can go and I can see, okay, so this is the schema. This is literally what the data will look like in Druid when I'm done with this process. And I can see, do I like it? Well, I don't like it because I can see like here I'm not getting any roll-up. Roll-up is a really cool concept in Druid. I made a whole video about it. It's something that makes Druid like super powerful. And I have a unique ID column here that I could delete. And maybe I also delete page because that's in Wikipedia, that's very high cardinality. And I can see I'm starting to get roll-up here. Again, if you're missing what I'm doing right now, if you're like, oh, I'm not sure what rollup is, it just know that this is really easily configuring something pretty important in the database and giving me a preview of what this data will look like. And finally, I just select the partitioning scheme, and for all of these, I have the inline documentation for what's happening here. Lastly, I publish it. I'll call this Wikipedia, and there is that spec. So this UI saved me from having to write this JSON. It's still showing it to me because maybe I'll want to like copy paste it and submit it myself, or have some job that submits it or something like that. It's still useful to be able to have access to it, but it's really a pain in the ass to write it, and you don't want to do that. And now it's going to start loading that data, and it's going to load that data onto my laptop. So it depends on how fast I can download it. It's not a very big file at all. And I'll have there's a task running right there. So I can check. I can get impatient with it and I can refresh. And it's actually already succeeded. This thing will auto-refresh every 30 seconds. I can change that. And then lastly, okay, let's see, data sources. There it is, my data source that I just ingested. I can query with SQL, and I have a select star already ready for me, and I can query it, and it comes out, and then pretend that I have no idea what SQL is, or pretend realistically that I don't care at all for writing SQL ever. Then I can just do like show on one of these things, and it actually added a filter, which is convenient, but not necessary in this case because I'm going to remove it because this data is a little older. And I'm going to get another aggregate in here. So let's do aggregate by sum delta. And I'm going to sort on the sum delta. And I'm having fun issuing queries to the database. And the whole thing took like a few minutes. So yeah, that's Druid. And it's easier to use now. And it's only going to get simpler. Yes, questions. And so, sorry, the gentleman behind you was raising his hand. So yeah, the question is about like count distinct, I'm assuming at ingest time. Or just at query time? Yeah, so you could, for example, click on flags, aggregate, count distinct. Oh, it actually didn't type in the distinct here because that is a bug that we fixed already in 017. 017 is going to be best. But imagine that worked first time, that you would get it.
Do I need to specify beforehand all the attributes I want to query? The count is by?
So in Druid, the way that the data modeling works is that you can either have something be like a dimension, if you're using rollup, a dimension, or an aggregate at query time. And if you have something like user ID and you don't want to have it as a dimension because it will blow up your rollup, you have to specify it as a sketch aggregator at ingestion time. If you're not using rollup, you can just do count distinct on whatever you want, and you can do count distinct on any like dimension in Druid. And one of the things we're actually doing is we're doing stuff. We're adding tools on top of this to make schema modeling easier, because that is still something that people like try to understand. And there's a lot of more intelligence in 017 that's going to come into that schema step I was showing. Yeah.
Are you going to completely drop the mapping support for those data?
No. I was making a joke. We're not going to completely drop MapReduce. Like nothing that you were doing before. It's not like you would not be able to do it then, like later, but you wouldn't have to do it. So a new user would potentially want to use Druid's native inbuilt capability instead of MapReduce.
But if I already have like a few hundred nodes, it's much easier for them to do most of the hard thing. Then I don't expect real-time query. I don't have to unnecessarily load the Druid cluster.
So the reason that Druid was designed the way it was originally with all these processes and all the dependencies and Hadoop and stuff like that is because that is actually an architecture that super makes sense if you are like ingesting if you're like you and you have the cluster set up and you are like all going. We're going to keep supporting that because this is like the fundamental people we want to use Druid. But for a new user coming in the first time, right now, like, I talk to Druid POC customers, like people in the community all the time, and a lot of people are like, what? I have to stand, like, my data is in HDFS and in Parquet. I have to stand up a Hadoop cluster just to load it into Druid? Like, we haven't used, nobody here knows how to use Hadoop. Like, we're like, well, like, are you in Amazon? Can you just use EMR? Like, but I don't want to like spend the extra money, like, and it starts like a whole conversation. Much simpler message, point your Druid at it, do it. And also, the data loader will support Parquet and HDFS.
We having plans to add some sort of access control over some of the functions. For example, if I log into this UI, then I can drop tables left and right. And there's no like access control. Anyone can log into it. There's no admin or users.
Okay, let me look. My sister lives just nearby. She has a baby daughter. My niece is a really cute girl. I was just over there before coming to the meetup, and I had my laptop open on our test cluster that and she was like crawling and banging on the keyboard. She almost stopped every single supervisor in the cluster. It was really cool. It's so simple, even a baby can mess up your entire cluster. So there is no concept of access control right now in this console, but it's something that we will be looking into. It will naturally hook into Druid's concept of access control. Druid has 2 levels of access control right now. If you set up users, you can have like an admin user who can basically do everything, and you can have like a read-only user. And you can also assign like read-only thing by like data source. One of the things we want to do is refine that, but right now this is how it stands. If you're an admin user, if you can see this console, it's just for you, man. It's not for your baby.
No, but anyone can log into this console, right? There's no request for credentials or anything. I just log into it. It's an open board. Anyone can log into it and start messing about.
Correct. If you're deploying a Druid cluster, either you configure users, which you can do in Druid, and then not anybody can log in, only the users you configured. Quick plug, if you're using Imply Cloud, then we can do authentication for you out of the box, whatever. If you're running a Druid cluster, then usually you restrict by the network who can log into it. So only people who can like VPN into your like EC2 or whatever can actually access it. But yes, whoever can access this can do anything, but whoever can access this could already do anything right now on your Druid cluster today. They just have to figure it out from the 100 APIs. Yes?
We have distinct measures. According to the data loader, is there anything that we can do to avoid just loading all of our raw data?
Yes. So in the data loader, you can create distinct measures there, and you can remove, like I removed 2 columns as part of my demo just now. And we're bringing a lot more query intelligence around that in the 017 release.
You can define distinct measures for different breakdowns, and the user needs the ability to see distinct measures for different breakdowns.
You mean when you say different breakdown?
Distinct per application, per country?
Yeah. Yes. You can define all of that right now in there, but by default it populates all of your rows and all of your columns, and you have to go through and drop them. So I dropped 2 columns, and I could have made them into distinct, like a unique page and a unique diff ID, but I didn't, just because in honor of time. But we're as I said, we're at in the 017 release, doing this will be even easier.
It's used like a window function.
Wait, now I'm not sure I understand what you're saying, because before I thought I knew what you're saying. Now I'm confused again. What window function?
You want to see distinct measures for different time breakdowns. You want to see per day, per week, per month. You want to see it per different dimensions.
Well, so you can do that at query time. So if you at ingestion time, you just have to specify whether you are ingesting something as a dimension within a string, which means it will have an index built for it, or if you're just ingesting something as a sketch column. And the sketch column is pretty can then be combined in whatever way you want at query time, which is where you would do it per different granularities of time. Just to be clear, there's nothing that you can do in console other than the cool. Actually, the only thing you can do in the console you couldn't do before is this cool SQL interactivity. Nothing that you could do before is something you couldn't do with Druid. You just had to know how to do it, and now it's more exposed. And there's also certain things that, when we put it in the console, we realized, man, we should really fix the API for that, make it a little bit nicer. But really, what you get here is the same thing you would have gotten before. So whatever data schema makes sense for doing that makes sense with the data loader or without the data loader. The data loader is just there to help you write the JSON spec. And as I said many times already, really, really cool advances are coming in 017.
Sorry.
Yeah, question. Is there any plan to handle duplicate messages during the ingestion?
So yeah, so duplicate messages during the ingestion that's a data modeling thing, and you could, depending on how your duplicate messages look like, I guess if you're just repeating the entire row, you could set up your rollup in such a way that it would handle that naturally in the way that it rolls up the data. If you didn't have another rollup on top of that, if you weren't also using rollup just as rollup to save you some space, so you could kind of repurpose rollup to dedupe instead of do real rollup. But that is.
It's kind of done a rollup. It's about all of the data.
Yeah, and then just takes the max of every numeric value, for example. But that is. That is a hack, yeah. No, really, if you're trying to properly dedupe data, you should do it in your Spark streaming job. Oh, yeah. So the question is there a way to define a custom partitioning besides the time column? You mean if you don't want to partition by time column, or you want? Yes, you can. And in fact, if you go to the partition step, you will see that there is a if you use the force force guaranteed rollup thing, which activates some cool features that I'm not going to go into right now. But basically, then you can add partition dimensions as a secondary partitioning thing, and you can read more about it from the question mark icon. So the question of like whether you want to like, so you basically want to have like one segment per customer per time chunk. So you could do that, but also from the query side, like the real place where you need to enforce that is on whatever is querying the data. So you need to make sure to apply the customer filter like every time you query that. It's actually one of the core value adds of Pivot, our solution that we built at Imply that works on top of this whole thing and is used in production by really big companies. But the idea for like from like so the only reason you would do it here in the database is just for like optimization, because you don't want like the like I guess the load of one customer to affect the load of another customer in such a way. That makes sense, and it like it probably doesn't make sense to really have like one customer per segment, because you want to avoid very small segments. You just don't want to. Okay, I guess we should take this conversation offline. It's a very long answer to that, but the answer is whatever partitioning you can configure, you can configure in Druid, you can configure it through here. And actually, you notice that like when I switch this to true, like a bunch of stuff lit up as blue. That means that it's required, so it won't let you proceed to the next step without filling it in. So that's kind of like useful, because it's something that's not like obvious to get from the document. I mean, it's not hard to get it from the documentation, but it requires you to read. But what's nicer than reading? Looking at blue borders. Just fill the blue borders in. What are they? I don't know. Check the information icon. Cool. Go ahead.
Nested data structures.
What? Data structures. Nested data structures.
I have records with sub-records, and I want to filter by them, aggregate by them. Is that even supported? And if so, what are the limitations?
Yeah, so that is, there is no support right now, like natively out of the box, to ingest a JSON blob as a value of a row and then do anything meaningful with it. I mean, you can ingest it as just a string, but you can't do anything meaningful with it. So it basically isn't there. What we advise people to do is that you can flatten the data at ingest time. So you provide what's called a flatten spec. And if you're thinking to yourself, man, what's a flatten spec? It must suck to write. Do I have to read the documentation? No, you don't. Because if you go to the parse data step, it knows that this is JSON and supports flattening. So you just click this like flattening thing and follow the directions that it gives you. So you can flatten data in this model. And actually in 017, there's also going to be an ability to explode data. So if you have a nested object with an array inside of it, you could explode that array out into individual rows. So for example, if you have like a feed of auctions, and each auction has an array of bids, and you want to have a data source of bids, you can like explode that out.
To edit as a column?
What? It would be added as a column, yeah. This data right here is actually already flat. So I could show you a flattening, but it would be like a trivial one. But we could maybe come up with some cool nested data in our heads, and then just type it into the paste data.
But that's 30 years from now.
That's yeah. Don't use it for 30 years. And 30 years from now, just start like don't even connect Druid to anything. Just like type everything in. Type all the data. I know it might sound like a lot because it's a big data system. How will you ever fill it? But you have to believe in yourself. So the question is Druid CPU intensive or memory intensive? I mean, the answer is both. It uses like all the resources of the machine. You know, like when they Intuits, they kill an animal, they use the meat and the bone and the. So Druid uses everything on the machine, and you need to, so those, you saw in the previous, in the slide that I was showing, there's like start, micro, quick start, like the difference between them is like the tuning. And there's some, like the different tunings are for different like sizes of machines. And actually, tuning a Druid cluster is another service that Imply provides to fully optimize it for your cluster needs and provide you the maximum amount of value. Everything is tied into a promotion. Yes, please.
Related question, a guy did ask about JSON. Is it possible to store like arrays, for example, as a single value?
So, arrays of strings?
Strings, numbers, booleans, whatever.
Yeah. So arrays of strings, yes. It's one of the very, very important features of Druid. It's called multi-value columns, and it's fundamentally built into the whole thing. So you could have, for example, like maybe each event is like a user visits your website, and maybe each event has like tags, which is the tags of that page, like automotive and sports. And it's an array, and then you can like filter on one of them or filter on both of them, and do all sorts of cool things. For arrays of numbers, not really, unless you turn them into unless you treat them as strings, because it's made for like this tags use case. If you have an array of objects in your data, like for example, array of bids inside of an auction, you could explode that out at ingest time when we ship the explode spec, which I hope will be in 017.
And a question about the modeling. So I see in the modeling you have dimension, right? So in my specific application, I have like hundreds of dimensions. It's very sparse, but lots of dimensions, but very sparse.
Yeah.
Is that a use case that Druid is a good fit for it or not?
Yeah. Druid is like a columnar data source, which makes it very suitable for stuff like that. If you have a column and it's very sparse because only like a few values are like filled in, it's stored in a very, very efficient way. And the index for it is very efficient. Everything is efficient. Do it. It's great. I've seen a cluster happily running with like 40,000 columns. 40,000. And I was like, ooh, that's a lot of columns. Actually, fun story. That cluster, that is how we discovered one time that we had a nested for loop inside of like the call site. The call site had a nested for loop inside of the planner, so it was like n squared instead of like linear, where it could have been linear. And there was a fun bug report to fix, but that was fixed, and then that and many other bugs were fixed, and then we declared Druid SQL as production ready in 015.
So Druid is now production ready?
What? Druid? Druid has been running in production. Right?
Incubation.
Oh, so the incubator thing is just, we're in the process of donating Druid to the Apache Foundation. And that incubator label is about the status of the project inside of Apache and how we follow the Apache rules. But even before Druid was even donated to Apache, Druid has already been running in production by like very large enterprises for a very long time. And it's absolutely treated as production ready. Every new release maintains backwards compatibility to the previous release, so you can do a rolling update. Rolling update and managing a rolling update is actually one of the services that Imply provides.
When is 17 about to be GA?
17 is going to be code frozen, and it's going to be RC probably like in a week or two, and we expect it to ship at the end, probably like first week of next year, or maybe by Christmas.
And 16 is already GA?
16 is out right now, and it's GA, yeah. Cool. Well, thank you so much for having me here. Thank you for all the questions.